Someone could just type in the box if you could hear my voice. Okay. Thank you everyone for joining. My name is Slava Akhmechet. I'm one of the founders here at RethinkDB. Thanks for coming to our very first official release webcast. What I'd like to do today, I know some of you are new to RethinkDB, so what I'd like to do is spend maybe about 5 minutes giving you a demo of just the basics of what RethinkDB is. And then I'm going to go and through some of the features in the 1.14 release and demo some of the cool stuff that we've done, which includes seamless migration, binary data support, and Python 3 support. So I'm pretty excited. We've been working on this for a while, for about 2 months, and I think it will be interesting for you to learn about these features. Okay, so let's get started with just a very 5-minute primer on RethinkDB. RethinkDB is an open source distributed database. It's a document database designed for real-time web applications. So if you're building web apps, mobile apps that have to deal with real-time data, or you're dealing maybe with web APIs or JSON, there's a very good chance that RethinkDB is a product for you. So to get started, I'm going to switch to my terminal here and just start up RethinkDB. Now, starting it as simple as typing RethinkDB on the console. So let's do that. I'm going to hit enter. And you can see that RethinkDB is up. So I'm running version 1.13.4. So not yet the newest release. And the server's up, and there are 2 ways you can connect to RethinkDB. So one way is via client drivers, and here's our port, client driver port here, and this is basically a way for you to connect and start executing queries from programming languages, almost any language you might be wanting to use. But another way to connect to RethinkDB is through a built-in web UI, and here I highlighted its port 8080. So RethinkDB ships with a web server and a modern web UI. It's pretty nifty. It lets you control the server and the cluster. And all you have to do to get into the web UI is just point your browser to port 8080. So let me switch to my Google Chrome here, and I'm going to type localhost 8080. Someone's asking me to zoom in. Can you guys see what's going on? I'm going to try to make the screen a little bit larger. Not sure if that's better, but I hope it is. Okay, so we are now in the admin console, and that's just built into RethinkDB. And what you could do here is quite a few things. You could look at the cluster performance, and there are no graphs right now because nothing's going on with the database. You could look at the log, do various administrative things. You could look at your tables, servers, and the cluster, configure sharding and replication, things like that. But what we're going to be working with today is what we call a data explorer, and I'm going to switch to that right now. And a data explorer is just a way for you to type queries interactively and execute them in RethinkDB, and it's very convenient for doing ad hoc data analysis or ad hoc operations. So there's an input box here where you type queries, and RethinkDB queries in the Data Explorer are basically just JavaScript. So any query you could type here, you could move, to a real JavaScript program. For example, if you're building your server in Node.js, and the same queries will work. So the first thing I'm going to do is create a table, and this isn't very different from any other database. The command to do that is table create. So I'm going to say r.table create. And create a table users. So R here is just a namespace. It's a package for RethinkDB. All RethinkDB commands are stored, are located in R. So anytime you access a command in RethinkDB, you have to say r dot. And I'm going to run this command. RethinkDB does its thing, and then we see a JSON document right here that says one table is created. And I can now say r.table users. And just run this command, and you could see here that we have no data in the table. So what's really nifty about the RethinkDB query language is that it's chainable. And when you type a command, you can keep adding commands, chaining commands at the end to perform more operations on the data. So if you ever used jQuery before, or maybe Linux command line with pipes, This is a very similar thing. Data flows from left to right, and it's just a very convenient way to build up queries interactively. So right now, let's say I'd like to insert a JSON document. So I'm dealing with my table users, which we just ran, but all I have to do to insert is say .insert, and in parentheses, I could just pass a JSON document to insert into the database. So let's say we have a document with ID 1, and I'm going to just insert a user, myself, so name Slava and age 31. I'm going to hit Shift Enter again, and you can see we get back a message saying that one document has been inserted into the database. So now the document, Slava age 31 is in my users table, and I cannot do manipulations with. So just for this demo, I'm going to insert another document with ID 2, name, let's say Michael. And suppose we don't have the age for this person, so I'm just going to get rid of the age part. I'm going to run this query. And again, we see that the document has been inserted. So as you can see, RethinkDB documents, the JSON documents don't have to have the same structure. You can insert documents into the table with different structures. And that has its ups and downs. But the main advantage is that this is extremely convenient if you're building web applications. So now let's run r.table again and see what documents are in the database. And you can see that, we got both our documents back. So I mentioned that you could chain RethinkDB commands, about a couple of minutes ago. So I'd like to give you an example of what that means. So let's say we'd like to get all the documents, but maybe just the username and age if it's available without ID. So I could say .without, and this command basically returns all the documents without the fields that I'm going to pass. And I'm going to say without ID. And if I hit Shift Enter, I'm going to get the documents back, but ID is removed. And I can just keep pressing dot and keep adding commands. So for example, suppose, I only want to get documents that have age. So I'm going to say dot has fields, which is a command that basically it's like a filter, but it's a specialized filter that gets you only the documents with certain fields. So I'm going to say has fields, age, and I only get Slava because it's the only document that has that field. So that's just a very basic, basic introduction to RethinkDB. You can insert documents, update them, which we'll see, get them back out, and you can chain commands almost indefinitely to do very sophisticated operations, which is a very convenient way to build up your queries. Okay, does anyone have any questions so far? If you have questions, please type them in the chat or in the questions poll. So in the meantime, I'm going to keep going. So before I move on to information about the 1.14 release, I'd like to show you one more command that's already in the database before 1.14, and this command is called r.http. So r.http does exactly what you might expect. It basically lets you access any URL on the internet, and it does this straight from the database server. So if I put a URL here, let's say I'm going to access google.com. If I execute this command, the RethinkDB server is going to go out to Google, grab the document and send it back. So I'm going to run this, and on the bottom here, you could see, this is the string, the HTML that Google sent back. Now, I'm going to introduce this command and show you how you can use it in a little bit more detail, because we're going to be using it later for binary data. Now, why did we build r.http? It's obviously not to get websites, although if you wanted to build a website crawler and crawl websites and insert them into the database, you could do that. But r.http is an extremely useful command if you're dealing with web APIs. So there is lots of services right now on the internet that operate via JSON. And pretty much, most modern web applications or mobile applications have to interact with these services. And the reason why HTTP is a really wonderful command and fits really well into RethinkDB is because RethinkDB is a JSON database. So you could just get a stream from an API and insert it into the database or start operating on it with REQUEL, the RethinkDB query language, which is extremely convenient. So I'd like to show you an example of this. Now, you probably know, if you've been following RethinkDB, that it's almost entirely, the development happens almost entirely on GitHub. And I just went to github.com. And that has, a number of benefits, like the fact, for example, that anybody who's using RethinkDB can look at the development process and comment on any issue. And the cool thing about GitHub, I'm just going to zoom in a little bit. The cool thing about GitHub is that you can start projects. And if you start projects, you can follow some of the things that are happening. So RethinkDB has over 6,900 followers, and I just clicked on the followers here. And you could see, all the people that are following the project. And GitHub has an API that lets you get the followers in JSON. So for example, I'm going to say the URL for the API is api.github.com, repos. I'm going to zoom in a little bit more. Oh, you can zoom in on the URL. So repos RethinkDB stargazers, because GitHub calls followers stargazers. And if you run this, let's zoom in on the JSON document here. We get a JSON document from GitHub that has all the followers here. And it's really cool because, for example, one thing we do is we really care about the people who follow RethinkDB, our users and the community. So we very often just, look at some of the people in the community who have been helpful or interesting, and we send them handwritten notes or T-shirts and stuff just to thank them for participating. And let's say we wanted to use, eat our own dog food and use RethinkDB to do this. So what we want to do is get the followers into RethinkDB and then start maybe doing something with the data. So I'm going to do that now. I'm going to copy this URL. And instead of google.com, we're now going to go to GitHub's API and try to get that data. So I'm back in the Data Explorer, and I just pasted the stargazers API for RethinkDB. I'm going to run this query. And you could see that the query got executed, the RethinkDB server went to GitHub, got the API call, and gets the JSON document back into RethinkDB. And what's really cool about this, and internally we use this all the time, not just for stargazers, but for just web APIs in general, is I can now use RethinkDB commands to operate on this JSON data. So just as an example, let's say I'd only like to look at people's login, which GitHub sends here, and for example a bio, which is just a description that the user writes down when they sign up for GitHub. So I'm going to do that now, and RethinkDB has a command called pluck, and pluck just lets you get only specific fields that you're interested in. So I'm going to get login and bio. I'm going to run this query, and you can see we're changing r.http and then putting pluck after that, and we scroll down. We only get, so actually maybe bio doesn't come with the GitHub API, but we only get the fields that we're interested in. Let me try just for a second to get another field instead of bio. Let's say we want login and, for example, ID. So I'm going to say .pluck login ID, run the query. Okay, and we've got the fields that we're interested in. So this is super cool for a couple of reasons. One is if you're just dealing with web APIs, this is extremely convenient for interactive use because in a couple of seconds you can get the data into RethinkDB and you could store it in a table if you wanted to. And then you could just start manipulating this data with REQL, which is extremely convenient for dealing with JSON data. And two is if you're writing applications that have to deal with web APIs, RethinkDB can act as middleware that lets you get the data in, manipulate it in various ways, and you can then use it from your applications, your clients. Okay, so that's r.http and my intro to RethinkDB. This is obviously just scratching the surface, but we only have limited time, and I already spent 15 minutes here, so I'd like to move on to demoing some of the features from the 1.14 release. But does anyone have any questions so far? Please type in the questions box or the chat. Okay. I don't think anyone has any questions, so we're just going to keep going. So what I'd like to show you now is the first feature from the RethinkDB 1.14 release, which is seamless migration. Now, out of the people here, how many of you guys have used RethinkDB before? If you've used RethinkDB before, please write in the chat or in the questions. But for those of you who have used it, RethinkDB had a very annoying or frustrating quality where if you were to migrate from release to release, you had to go through a migration process. So for example, if you were running RethinkDB 1.12 and then you needed some features from RethinkDB 1.13 and you wanted to upgrade, so what you had to do is you had to dump the data from RethinkDB 1.12 into a file, then upgrade, and then re-import it back into the next version of RethinkDB. And this was extremely frustrating to a huge number of people. And we actually had, so the GitHub issue for migration had, I think, dozens or hundreds of comments by people saying, please fix this. Because dump and restore is actually a pretty long-running operation. If you have a lot of data, it could take hours or even days, which meant that if you wanted to upgrade, you had you could potentially have days of downtime, which is just unacceptable for production or real-time applications. But this kind of migration was necessary because as we were moving from internal formats, file formats, and memory formats, it was very hard to keep backwards compatibility, and it required quite a bit of re-architecting of the server. And all of that work has finally been done for the 1.14 release. So 1.14 has a seamless migration. And I'm going to show you how that works now. It's really beautiful and very simple. So I'm going to switch back to my terminal here. I'm going to zoom in a little bit. I hope you guys can see better. And I'm going to shut down RethinkDB 1.13. So what I'm going to do now is start RethinkDB, but I'm going to start the RethinkDB 1.14, and I'm going to do it from the development branch because the release isn't out yet. But it's the last commit on the 1.14 branch. So I'm going to say /RethinkDB now because I'm in the directory. I've just built this just for this webcast. I'm going to hit enter. And now I've started the latest 1.14x RethinkDB. And you can see if you look at the version here, there is this bit that talks about the latest build. And it's on the 1.14 branch. So this is the build you're going to get in a couple of days when 1.14 is out. Now, this process took, a second, but before I would have to, so the two documents that I just inserted, I would have to export them via command line tools and re-import them back in. So now people don't have to do that anymore. If you want a newer feature, you could just upgrade, start the new version of RethinkDB, and it will work. And it's really, really wonderful and extremely convenient. So it will save, I think this feature will save people, hours or days. And it was really hard to do, so we're very proud of finally getting this in. So now I'm going to go back to Google Chrome and go into the Data Explorer. And just to prove to you that this works, I'm going to run a query to get the data out of the users table. And I'm going to run this query, and you can see that we've got our documents. Okay, so that's the first major feature in the 1.14 release, seamless migration. Now I'm going to move on to the second feature. And in the 1.14 release, the second big feature that we're adding is support for binary data. So I'd like to demo to you how this works, and it's really, really convenient. You can now store binary blobs inside a document. So it could be something like images or audio files or any kind of binary files, any kind of binary data that you'd like. And the way I'm going to demo this is I'm going to use the gravatar API to show you how this works and to show you how it interacts with the r.http command. It just fits absolutely beautifully. So let's look again at our stargazers for RethinkDB. These are stargazers on GitHub, all the people that followed it. And you could see that stargazers have little avatars, the icons. And these icons come from a service called Gravatar, which is built by WordPress in the open source community. And if I go to gravatar.com, I actually have a gravatar there, and my username on GitHub is coffee mug, so my gravatar is, of course, a coffee mug. And by the way, I had an old pixelated one before, but now I have a new, brand new spanking coffee mug, which I'm super happy about. So what I'm going to show you is how to use the gravatar API to get images and store these images in RethinkDB. Now, the way gravatar works is it has an API where you could get get any image for any user's email address. And GitHub actually uses this service, and a lot of other services do too. I think Twitter uses that as well. And the way this works is really great because you just set up your gravatar icon once in gravatar.com, and then all these other services will just get it out, so you don't have to redo it for different websites. Now let's look at how the gravatar API works to get the profile icon. I'm going to say in Google, just search in Google gravatar API, get image or something like that. And my first link is image requests. So let's go there. And this document is on gravatar.com explaining how the gravatar API works. So the gravatar API, you basically go to, gravatar.com/avatar, and you have to pass a hash. And a hash is just an MD5 hash of a user's email address. Now, my email address happens to be coffeemug@gmail.com. So what I'm going to do is run an MD5 command on this email to get the hash, and then I'm going to try and get my avatar from gravatar. So first I'm going to copy the first part of the URL without the hash and just type it into Google Chrome in the URL. And now I'm going to go back, open another terminal, just zooming in a little bit so you hopefully can see it. And what I'm going to do is generate an MD5 hash for my email address. So I just typed that here. You can see my email address is coffeemug@gmail.com. And all I'm doing is just running PHP where I echo the MD5 of my email. So I'm going to run that now. And I get the MD5 hash for my email. I'm going to copy that here. So it starts with FED and ends with F20. So I hope you guys can see this. I'm going to copy it and then go back to Google Chrome and just paste that at the end of the gravatar URL. So let's hit enter. And I've got my icon. So this is an icon for my email address. And if we look at the stargazers on GitHub, all of these guys and girls probably have an icon set up on gravatar. And this is how GitHub gets it. So in RethinkDB so far, we've inserted some users, but let's say we wanted to also store the avatars, cache the avatars in RethinkDB. So if we had our own website, we could display it in the browser. So what I'm going to do is just copy paste this URL for my gravatar. I'm going to switch to RethinkDB. I'm back in the Data Explorer where I can type commands. And I can say r.http. And here I'm going to pass the URL for the gravatar API, where this is the URL for my gravatar. I'm going to hit Shift-Enter to execute this query. And you can see in the Data Explorer, the output is a 6.5 kilobyte binary blob. So what's really amazing about this, and actually what's really cool, about RethinkDB in general, and we try to do this as much as we can, is we try to have all the recall commands and all the recall features integrate together very tightly. So when we've added, the binary data support, we made sure that it integrates with everything else, every other command, and in particular, it integrates with r.http. So you can just get binary data anywhere from the internet via an API or, really any image, and just store it as a RethinkDB blob and a RethinkDB document. So this works really nicely, and let's actually look at this feature. So I'm going to type r.table users. Let's see, so my document for Slava has ID 1. It's right here. And let's say I'd like to update this document and insert my avatar into the document. So, later if I build an application, I can show this icon to people in the web browser. So to insert the avatar, I'm going to say .update, and .update is just a command that lets you update the document. And I'm going to pass a JSON document that says icon, I'll call it icon, and the r.http command. So what's going to happen is I'm going to update my document with this avatar. And if you just type r.table users.update, what's going to happen is it's going to update every document in this table. But my document has ID 1, so I'm going to say .get 1. And what will happen here is it will get my document and then run the update command on it. And in it, it will go out onto gravatar, grab the icon, and then store it. So let's actually run this. And I get an error. The error says, could not prove function deterministic. Please use the non-atomic flag. So this is something I'm not going to get into in detail because it gets a little bit into the guts of RethinkDB. But basically what it says here is that the r.http command is non-deterministic. It's not a command in the database because this is going out to the web, and this can fail, for example, if your network connection is down or if gravatar is down. And the reason why it's important for people to know this is if you're running RethinkDB queries, this command cannot be optimized. So there's this error message, and to just get around it, we have to pass a flag non-atomic equals true, and then what this does is tells RethinkDB that, okay, hey, we know that this is non-atomic query, it can fail at any time, don't worry about it, so I'm going to rerun this. And I get a JSON document back out saying that one document in my table was replaced. So let's actually look at what happened. So I'm going to say r.table users.get1. So this just gets the document with the UID 1, with the ID 1. And bang, we've got my document for Slava, age 31, except now we have an icon, which is a binary blob. Okay, so this basically lets you store binary blobs in RethinkDB, and you could use, you could of course use traditional languages to do it. You could store files, and this is something I'm going to show you next. So what we're going to do next is get this data, get the binary blob out of RethinkDB using Python, and store it on the file system. Okay, does that make sense so far? Does anyone have any questions? Please type in the chat or in the question box. Okay, let's see. I got one question here. And sorry, this is taking me a minute because the webinar tool is a little clunky. So the question is, when is it a good idea to store binary data in RethinkDB versus using something else like S3? That's actually a great question. So RethinkDB binary data support is very similar to what you get in SQL databases. And SQL allows you to store binary blobs of various sizes. So this is quite similar. And because RethinkDB is distributed, you can sort of use it as a distributed file system, but it's not quite as sophisticated as S3. And it's different for a couple of reasons. So it's not a service, right? You have to run RethinkDB yourself. That's the first thing. The second thing is, right now, the binary data support is not actually designed for large files. So you could store something like avatars or small files or small blobs, probably up to a megabyte or maybe a little bit more quite easily. But if you have really large files, like gigabyte-sized files, the binary data support isn't quite right for it. So S3 would be way better for large files, or if you just want to run a service. On the other hand, if you already are running RethinkDB or building your application and you're storing small files like avatars or things like that, RethinkDB is actually really great. The binary support is a really great tool. You can just store it right there. You don't have to learn how to use another service. You don't have to deal with another API. And it integrates beautifully into the rest of the RECO language. So I also got another question from IRC. Someone saying, how much can I really fit into RethinkDB? And where is the blob stored? Is it stored in a file or in the index? So right now, there are no limitations on the size of the binary data. You could store as much as you want. But in practice, there would be performance limitations if you try to store large documents. So if you store, a gigabyte-sized binary blob, you will probably encounter very serious performance issues. And RethinkDB is better. The binary support is better for smaller documents, up to about 1 megabyte. Now, as far as where the blob is stored, it's not stored in a file. It's stored in the RethinkDB data format. And it's really wonderful because you can index them. You can filter by them. You could search by blobs. You could use commands like plot. And it's just part of the RethinkDB table and part of the RethinkDB data file. So you don't have to worry about storing it anywhere else. It's completely handled by the server, and it integrates into the rest of the product really nicely. Okay, so what I'd like to do next is show you how to get the binary blob out using a programming language. I'm going to switch back to the terminal here. And see, let's kill this. I'm going to open a new terminal and zoom in a little bit so you can see it better. So I'm just going to switch to a different directory with the latest RethinkDB Python driver. And we're here. And what I'm going to do is start the interpreter for Python 3. And as I mentioned in the beginning, Python 3 is the first big feature in the 1.14 release. So up to 1.14, you can only use Python 2, and we've had a lot of requests from many different users to add Python 3 support. And this actually took quite a while to build, and we're really proud of this feature too, because adding Python 3 support wasn't something as simple as just migrating, updating the driver to work with Python 3. It was quite a bit more sophisticated because prior to, I think, the last release, RethinkDB used protocol buffers, which is a library implemented by Google, for the interaction between the driver and the server. And unfortunately, Google didn't merge Python 3 support into protocol buffers, and I don't think they're planning to. And it's a very sophisticated library, so it's not something we could have done easily. And in order to support Python 3, we actually had to get away from protocol buffers and add a JSON communication layer between the driver and the server. And we did it for a couple of other reasons, mainly performance, because it performs better than protobufs. But now that we no longer have to use the protocol buffer library, we were able to move to Python 3 pretty quickly. So now the RethinkDB driver supports Python 3. Okay, so what I'd like to do now is I'm now in my Python 3 interpreter. And what I'm going to do is first import the RethinkDB package as R and connect to the RethinkDB server. So I'm going to say r.connect, and I'm going to tack on .REPL, which you wouldn't actually do in a real application. But if you're just using the interpreter interactively, .REPL basically stores the connection. So you don't have, so when you run queries, you don't have to pass the connection variable all the time. You could just type the query and it runs. So you can see we've got the RethinkDB connection object. We're connected to the server. And now I'm going to run a query to get the documents from my table users. So actually what's interesting and really helpful is that various drivers in different languages actually look really similar. So the Python driver is extremely similar to the JavaScript driver. And if you know one, you can very easily use the other. So it looks exactly the same. You can say r.table users, and I'm going to get my document with the ID 1. It's the same exact query as we type in the Data Explorer in JavaScript, except now because we connect from the programming language instead of the web UI, we just have to tack on .run, and .run will take the query, package it, send it to the server, it will get the whole thing, the whole query will get executed on the server and send back the result. So I'm going to hit enter, and you could see we got our document back, ID 1, we've got our binary data, and name Slava. So what I'd like to do now is store it in a file. And to do that, I'm going to run this query again, except I'm going to change it a little bit to just get the field icon, or get the value of the field icon. So I have to add, brackets icon, and this looks just like Python code because it is Python code, except the whole thing gets executed on the server. So if I run this, I get the binary file, and I'm going to actually assign it to a variable icon, so I could use that later. And the next thing I'm going to do is open a file in Python. So let's say f equals open, and let's call it coffee mug or coffee.png. So I'm opening a file, and I'm opening it for writing, and of course I'm storing binary data. So that's why I pass WB. Okay, we've opened our file, and now I'm going to say f.write icon. So the binary data that we got back, we can just write it straight to a file. You see that we wrote 6,600 bytes, a little over 6,600 bytes. And now I'm going to close the file. So I'm going to say f.close, exit the Python interpreter. And now let's see how this works. Let's open this file in OS X and see if we can actually get the icon out. So I'm going to say open coffee.png, and let's hit enter. And we've got our icon. I hope you guys can see this. I know the software can be a little bit laggy, but we just got it out of RethinkDB and stored it in a file with Python 3. So what's really cool about this, you can now use any version of Python, and the binary blob integrates really nicely with the drivers, particularly official drivers like Python, Ruby, and JavaScript. In particular, so in Python 3, there's a type bytes that lets you store bytes, and that's basically what you get out of the database. So if you are dealing with the file system or networking or anything like that. It just integrates seamlessly, and you can use it. You can store things in RethinkDB, and you can get it back out. So that's our third feature, Python 3. And I've been trying for this webcast to show how all the features like HTTP and binary data, and Python 3 support and things like that integrate with each other. And I think this is, for real-time apps, building real-time apps, this is a really, really fundamental part of the product, to make all the features integrate with each other in a way that just provides an extremely pleasant experience to users. So we're pretty excited about these three, and the 1.14 version is not quite out yet, but it should be out tomorrow or almost certainly early next week. So, I hope you guys download it and try it. So I think I'm done with the demos for 1.13, or sorry, 1.14. Does anyone have any more questions about anything here? I'm just going to give you guys a second to see if anyone has anything. I know this can be a little clunky to type in. Okay, someone has a question on IRC. I'm just going to read that back out. So people said back to larger files. When I try to write a large file into the system, when it returned the icon, did it get the whole thing at once and then take in memory, or is there a way to split the binary file into chunks? If I have limited memory, it would not work well. So this is actually a great question, and you can split the file. So let's take a look at how that works. So I'm just going to get the icon. So I'm back to the Data Explorer, and what I'm going to do is try to get, not the full icon, because if the file is large and you don't have enough memory or something, there might be a problem with just a part of the icon. So let's try to do that. I'm going to get the icon value out, and you can see I just got my binary blob. So to get parts of the binary blob, you could use a slice command. And I'm actually not sure if it's implemented in this development branch, but we're going to give it a try. Let's see. So I'm going to say slice, for example, 50, and let's try to run this. And you can see, so I tacked on .slice 050, which says give me 50 bytes. And you could see that on the bottom, we got a result back, which is a binary file of just 50 bytes. So you could use the slice command to operate on binary data, and you can just get chunks of it. So in fact, if you do store a larger file and you don't want to get it all at once, you want to stream it or just get parts of it, you could just do it using the slice command. So it's quite convenient. And slice is the same command that also works on arrays, for example, so you don't have to learn anything new. It just works in the same way. Okay, there is one more question. John B asked, are there any limitations on new bulk return values? So RethinkDB 1.14 actually has a couple of other features that I'm not going to go into this webcast, but since John asked the question, I'm going to cover this. So RethinkDB has this feature, and we saw the update command. So we called update on my document. Document was the ID one, but we could also call it an update on the whole table. So for example, update, let's say I'm going to insert a fake field with a value 1. I'm going to run this query, and we get a document back that says replace 2, which means we've replaced 2 documents. And if I run r.table users again, you could see that fake field is present in both of the documents. Now, with update or replace commands, when you're doing that, as a user, you might be interested, okay, I've just updated the value, but what was the previous value of this field? Or for example, so this is very common when you're using counters. Like imagine you have a video on your website and someone watches the video, so you want to increment the view by some number, but you also want to know what the previous value was, let's say. So RethinkDB 1.13 had a way to do this, but only if you update on one document. In the upcoming release, the 1.14 release, you can now perform this operation on bulk updates. So if you do bulk updates on multiple rows, you can get the old values and new values for every single document. Now the limitation here is that you can only get up to 100,000 of these. And the way this works is when you get the old and new values back, you don't get a cursor, you get an array. And by default, RethinkDB arrays are limited to 100,000 values. And actually, in this release, you could also change this. So you could set it to 200,000 or 50,000 or really anything you want. But by default, you're only limited to 100,000 values. And if you do a bulk update and request to get previous values of the fields, you're only going to get 100,000. But you can change this by just passing an optional argument called array size and say, give me more, and you'll get more. So that's the only limitation. Let's see, one more question on IRC. Can I use the iterator for this? Sorry, 1 second. Questions are jumping a little bit. Can I use the iterator for this so it's not a lot of small documents? So no, there's unfortunately no way to use an iterator or a cursor to stream a single binary document into the client. This is something we're thinking about, and there's an issue on GitHub called distributed file system. There's been a lot of debate about it, and we've been thinking about a way. Okay, this feature is great for small documents, but how do you store larger documents in RethinkDB, and how do you stream them? And this turns out to have a very sophisticated set of technical trade-offs that I unfortunately don't have time to get into here. But this is something we're looking at, and we're hoping to ship a much more comprehensive distributed file system built on top of RethinkDB and on top of the binary blobs that we've implemented so far, which is kind of a stepping stone. So if you're storing large documents, you'll be able to stream them into your client and shard not just the table, but a particular large file and things like that. So this is coming up. This is it's being discussed now. We haven't started implementing this yet, but we're hoping we can ship this soon. Okay, so we've got one more question, and Joe Kim, I hope I'm pronouncing your name correctly. I'm sorry if I'm not. Says, I looked at RethinkDB drivers lately and saw that the Python implementation is much larger than the Ruby implementation. Is that due to the protobuf issue? Which driver should I look at if I wanted to port to another language? So this is actually a great question. So our official drivers right now are Python, Ruby, and JavaScript, and there are lots of community-supported drivers. But every driver was written by a different person inside of RethinkDB. So the Ruby driver was written initially by Michael Lucy, and the Python driver was written by a couple of people, I think Kim Maxwell, Joe Doliner, and Bill Rowan. And so these are completely different developers that have a different approach, to building software. And Michael implemented it in a way where a lot of the commands were generated from the protocol buffers. So, we looked at the protocol buffer definition file, and he generated commands automatically. So the driver is much smaller because a lot gets generated. And Bill and Joe, and I think to some degree Tim, didn't like that approach, so they built a Python driver in a way where everything is explicit. So because there's no monkey patching, or they didn't like monkey patching, they wrote the code explicitly instead of later monkey patching the driver to have more commands at runtime. And the drivers, and there's like no reason for this, right? You could do it both ways in either driver. It just so happens that different people wrote them, and the Ruby driver is written one way and Python driver is written the other way. So if you're interested in building a driver for RethinkDB for any language, first of all, we really appreciate it. It's great when people contribute community-supported drivers, and there's already over a dozen for different languages. So, if you want to build a new one or you want to join an existing project, that's absolutely wonderful. Thank you for that, and we really, really appreciate it, and we'll support you all the way. But in terms of just looking at the code, I would recommend understanding. So you can either look at some of the smaller community-supported drivers that don't implement every command because it's easier to get started this way. Or you could look at Python or Ruby or JavaScript, whichever language you're more comfortable with, more. It doesn't really matter all that much. There's just different styles of writing the drivers, and you can pick whichever one you understand better, or whichever one appeals to you more. And I think what we're going to do, I believe, an engineer at RethinkDB, Josh, is probably here in this webcast as well. But we're going to be writing a canonical example driver and a tutorial on how to build drivers. So you can look at the tutorial and get started with your language. So hopefully this will get a lot easier, soon. But for now, you can look at any driver you like. It doesn't matter all that much, just whatever appeals to you more. Okay, are there any other questions I can answer for you? See, I'm just checking here because the software is a little tricky. Okay, I think we're out of questions. So thank you guys again very much for joining the webcast. RethinkDB 1.14 should be coming out in the next couple of days. Please give it a try, play with it, and I hope you enjoy using it. We've put a lot of work and effort into it. We're very proud of it. And if you have any questions about it, if you run into any issues, or you just need help, please talk to us. You can submit an issue on GitHub. You can talk to us on IRC, on the Google, the email group, or just go to rethinkdb.com/community, and there's, you'll see different ways to reach the engineers here. We'll be super happy to help you out, hear your feedback, and if you have any ideas on features, that you'd like implemented, we have a huge backlog that we're working through, and we're actually excited about the 1.15 release that's coming after this. It's going to have a lot of really exciting stuff, but if you have more ideas or things you'd like, please let us know, and we'll try to schedule it into the product. Thank you very much again for joining this webcast. I hope you enjoyed it, and I'm looking forward to doing another one for 1.15. Okay, bye.